Hello and welcome to Future Building. I'm Mathew Aitchison and I'm Professor at Monash University and CEO of Building 4.0 CRC. In this podcast, we take a broad look at buildings and building in contemporary society and what's coming down the pipeline in the future. We'll talk with invited guests and experts in the field, where we'll cover news and trends along with research and developments in the industry. Future Building is proudly sponsored by Building 4.0 CRC. Welcome to the Future Building podcast. We have something of a milestone today in that we've got a repeat guest. Well, kind of. I first came to Brian Potter when a friend recommended I should read his newsletter back in 2021. The newsletter is titled Construction Physics. At that time, I recalled reading several posts from Brian about construction productivity and prefab, but the standout post from the period for me was Another Day in Kateradise from June 2021. That post was an insider's account of Katera, where, as an engineer, Brian had been an employee. And in his post, he discussed what it was like to work at Katera, and he even included a few hints at what had gone wrong, and in some cases, what had gone right. So way back in December 2021, we recorded a panel discussion with Brian and some others titled Deconstructing Katera, which you can find at episode 8 of this podcast. Since then, Brian has gone from strength to strength. Construction Physics now has over 61,000 subscribers and has expanded from pure construction into energy, infrastructure, and technology. Brian's ability to summarize complex issues, his command of the detail and presentation of key data in a really non-preachy, engaging way has established Construction Physics with a cult following. For those of you who have never read Construction Physics, Brian categorizes his essays into two main baskets. One, the explanatory topics, and two, exploratory topics. Often Brian's stories are a kind of what if. What if we could do a back-of-the-envelope cross-sectoral comparison, or what if we imagine then and now scenarios? How should we understand a really, really complex thing in modern society? References to construction physics have begun to pop up in the most unusual places, certainly in my life. For example, in a recent meeting I had with an economist employed by the Australian Government's Productivity Commission, and this suggested to me that it was long overdue to get Brian back on the podcast in his own right. So in April 2025, Brian provided us with the perfect opportunity, and because I can't say it any better than he did, I'll quote him at length. I've been writing construction physics since September 2020. Over the past 4.5 years, I've written 186 essays, totaling around 600,000 words. The newsletter was originally focused on understanding the problems of construction productivity, though it's never been entirely about that. But I've branched out to write more about a variety of topics, including energy, transportation, and scientific and technological process. So today, Brian and I will sift through the 50 learnings for what Brian calls the, and again I'm quoting, high-level takeaways, interesting or surprising facts, and things that gave a major update to his worldview. For me, some of the highlights of today's interview was Brian's insistence on needing a correct theory of change, in his words, before starting out to change something in the construction industry. I thought that was very interesting. And also how to improve productivity, or in some cases, how not to improve productivity. Looking at the correct question, looking at the correct data and assumptions that go into any venture to change the way that things work. So I really hope you enjoy our interview. I spoke with Brian from his home office outside Atlanta, Georgia in May 2025. Brian, welcome to the show, or should I say welcome back?
Yeah, thank you for having me. It's great to be back on the show.
Brian, we often like to start this podcast with an overview of the life and indeed career journeys of our guests, and I really think yours is an interesting one. So with your permission, I'd probably like to start a little bit with your background. As I understand it, you studied civil engineering at Georgia Tech, and then you went on to do a master's in systems engineering at the University of Central Florida. Now, I have to confess to you, I'm very familiar with civil engineering, but I know much less about systems engineering. Can you tell us a little bit about that?
Sure, it's kind of like a little bit of a grab bag of engineering topics that give you a sort of a better grasp of like how to do different sorts of engineering at kind of a high level. So it includes some stuff with engineering management. It includes some stuff about like operations research and logistics and kind of stuff like that. So basically it tries to instruct you like the similarities between different engineering systems, at the higher level of abstraction, what sort of problems you can encounter and how you can kind of deal with them in various ways.
Well, I'm glad I asked that because I don't know if I'm any great as a Sherlock Holmes here, but that does strike me as really relevant study to construction physics, which we're going to get onto soon. How would you say that education has formed or influenced the way you look at things now in the work you're doing?
Yeah, it was definitely useful. It gave me some exposure to a kind of a lot of different ideas and concepts that I probably would not have encountered otherwise. It ended up, for a while, it proved pretty useful to have a master's degree, so that, just having that sort of achievement was it was useful as well. So it was useful at the time when I got the degree. I was sort of not 100% sure the direction I wanted to take my career in, and it seemed like something that would kind of potentially give me a jumping off point into maybe going in various different directions, which I guess ended up being true. But that is what ended up happening, although certainly not in the way that I anticipated.
So, as we heard in our introduction, we met through your involvement in Katera principally. You worked obviously for Katera. I'm just wondering if you could tell us a little bit about the company and how it was that you came to be there, Brian.
Sure. So I joined Katera. In I think 2018. And at the time I was as working as a consultant as an engineer for a concrete manufacturing company. I was looking around for something new, and this was a startup that I had heard of, and I knew that they had raised a huge amount of venture capital money. I knew that they had really, really big ambitions to, they were going to change the construction industry and make everything more efficient and do all these fixes that I thought the industry at the time really needed. I thought it needed somebody to come along and try to make the industry work better than it did. So I was very, hopeful when I applied to join. I was very excited when I was accepted, and then I joined as a sort of engineer to sort of grow and lead the structural engineering office in Atlanta, Georgia. And so I stayed there for about 2.5 years until I left to join another engineering firm.
Ah, great. Well, that sort of led me to my next question. You went on to continue working as an engineer. Um, are you still employed by that engineering firm?
No, I worked for them for a couple years, and then after I joined Katera because I wanted to, I had sort of ambitions to try to do something to help, try to help improve and reshape the construction industry or just the way that we build things, and that didn't end up happening. Obviously, Katera went bankrupt some time after I left. At the time I left, it was obvious that they were not going to fulfill their goals. And so I left when things were on the decline, and they ended up going bankrupt after that. And then I joined a much more conventional engineering consulting company. And but I still had sort of ambitions that I wanted to find some way to sort of improve the way that we build things and change some of these things that I felt needed changing. And so I was constantly thinking in the back of my mind what would need to what would need to happen to sort of make those changes possible. So I stayed at this engineering firm for a couple of years, but after a while, I started actually right after I left Katera, almost, I started writing the newsletter Construction Physics. And so for a while, I was writing the newsletter just kind of in my spare time, in my off hours. And then after a while, the newsletter sort of got popular enough, it started getting some interest from people that I got connected with this think tank, Institute for Progress, which at the time was just starting up. They were sort of getting ready to unveil themselves to the world, and they sort of had been a fan of my work with the newsletter and said, "Hey, we would like to sort of, support you in any way that we can." And so what ended up happening was that they ended up sponsoring the newsletter for a year. And then around that time, I ended up, left this engineering firm, and then I sort of was experimenting with kind of other different ideas, some sort of ideas that I felt like were maybe promising in the construction field. None of them really panned out very well. But the newsletter kept getting more and more popular, and it kept growing and growing. And then so after a year with IFP, they were kind of, it's like, okay, we've been very happy with how this sponsorship has gone. We would kind of like to continue it in a way that works for you. And at the time, I was basically ready to sort of have some, move on to something a little bit more permanent. And so what ended up happening is what I joined IFP full time. And so now that's where I still am today as I work for IFP, but my basic job is 90, 80, 90% of it is to write the newsletter. And then I also do some other work for them on specific projects related to infrastructure that they have. But mostly what I spend my time is writing and researching various essays for construction physics. So that has now become my full-time job.
Wow, lucky you. I want to come back to um, some of the issues around the origins of the blog, but just while we're on the Institute for Progress, could you just tell us a little bit about that institute and what their mandate is?
Sure. So they are a nonpartisan think tank based in the US, and their goal is to sort of advocate for technological and industrial and scientific progress broadly. So make it easier, make our, our scientific research to be more effective and get more money to it where there's, valuable research that can be done. Make it easier to build the sort of infrastructure that we need to build in the US. Make it, um, have, do more R&D, and direct that R&D to sort of where it needs to be done. Have stronger industries, especially in the areas where the sort of those, future industries where they're especially important, things like AI and stuff related to that. So it's basically kind of yeah, sort of a progress, focused think tank along those specific lines and avenues.
Great. So coming back now to the origins of construction physics, did you have any role models or whether sites and authors or content creators that you were modeling it on, or did you really, how did you come up with it?
So when I started it, I didn't really have, I had writers that I admired in the sense that, oh, I like this, this online writer or whatever. It would be nice if I could write as well as they do. And, it's definitely, that's, so that a role model in that sense. But in terms of somebody doing the same sort of thing, I, I don't think I really had anyone specifically, and I really wasn't thinking about this as like as a sort of what would become my main sort of work at the time. At the time, why I started it was because like I had just been at Katera. They had sort of, failed at their mission extremely ignominiously. They had sort of, raised this very, very huge amount of venture capital and then spent it all without a huge amount to show for it. And I really felt like the industry still needed to be, changed. And it felt like I really needed to improve the way that we built things. But it was clear that we as sort of a society or a civilization didn't really understand how that needed to take place, what specifically you would have to do to sort of make these improvements. The sort of thesis that Katera was operating on, and a lot of other people have been operating on, was that if you just can sort of build your buildings and factories, then you'll get the benefits of factory-based construction, and all the sort of efficiency improvements, and stuff that goes along with it. And that didn't really turn out to be true. It's not really true for Katera, and many other people have gone sort of bankrupt with the same model. So it was clear to me that we didn't really understand what specifically needed to be changed. We had sort of a not very good theory of construction and what was wrong with it. So I've kind of felt at the time that I need to just understand the industry better and what specifically makes it so difficult to change. So at the very early stages, I was basically just writing for myself as sort of an exercise to try to understand the industry and work through these various, concepts and what was holding back these various improvements that people were trying. And so I was just writing as a method to try to understand it better, which is why I had this sort of, I'm sure courage and to start it at all because I didn't feel like I was, putting myself out there or making a bold statement to the world. I felt like I was just, I'm gonna sort of, this is gonna be the vehicle that I will use to try to increase my personal understanding of these things.
That's a lovely beginning, Brian. And I think starting in the way you did without hubris and really out of curiosity and the will to knowledge, I think is really still shines through in the newsletter now. When you read the stories, there is very much a lack of ideology, and I mean that in the most positive way, frankly. You're not pushing a barrow of any description. You're trying to let the data speak for itself, and you're sort of looking fairly analytically and objectively, I think, at what's been done and what could be done better. So I really feel like the sort of origin moment shines through there. Again, perhaps back to the origins a little bit. I just wonder at which point did you start to put down rules about how you create the posts? Were there specific topics? Was there a length? Was there a kind of type of argument or article type? Did did that happen immediately, or did you just feel your way into that, Brian?
So at the very beginning, I was trying to sort of make it a habit as much as I could, because historically that has been, a useful structure to me. It's like, if you have a set schedule and you're going to do this thing repeatedly, it's much easier than if you sort of have a little allow yourself more flexibility. So one thing that I tried to do early on was I tried very hard to post once a week. And, I built sort of my schedule around, posting something once a week, which is not, a lot for some writers, but for me, it was a lot. I've never been somebody that can just crank out huge amounts of writing. And, the time it took to actually do the writing and the time it took to sort of do the research, that was somewhat, turned out to be somewhat, I think just the right amount of sort of aggressiveness, any sort of tighter timeline would have been very, very difficult, and anything sort of more relaxed would have been like sort of a little bit too easy and a little bit maybe easy enough to sort of give up on it. So I think that was an important rule in the beginning. And then very early on, I was very, very focused on understanding the sort of nature of the construction industry and about specifically like construction productivity more broadly. And so if you read like kind of the earlier posts, they're very specifically focused on those sorts of things. And then as time has gone on, I would say the biggest change in the newsletter is that I've really, really expanded the
Hmm.
things that I write about. And that's there's a couple different reasons for that. One is that as I started doing work with IFP, I've always followed my own interests in things that I want to write about, but if I also want to sort of do work that is, valuable for them, and so what they consider, what is interesting to them is they have a much broader mandate where they're focused on things like infrastructure construction and transit and energy stuff and things like that. And so I've broadened my mandate and broadened the things that I write about in part because of my employer and what is valuable to them. And then also it's just kind of more gradually. As I've learned more about things, those provide, avenues and footholds into new topics. And I've always just found, always just followed kind of my interests wherever it goes. And so if my interests lead me to some new kind of subject or whatever, I've pretty much just allowed myself to dive into that as I feel like I am able to do so. So I've, expanded it into things like shipbuilding and aircraft construction, which often these started out with like related to construction specifically, but as I learned more about it and had more questions I kind of wanted to understand and answer, I branched out into just sort of writing
Mm.
about those things directly. So what I've sort of settled on now is I've described it as writing about buildings and infrastructure and what I call industrial technology, which is sort of big, manufacturing and big heavy machinery and things, all these sort of big building projects that make, society run but it's really what it is just sort of a big circle around the topics that are interesting to me. And I feel like I have the capability of writing something compelling and valuable
Mm.
about.
That's, yeah, I feel like perhaps I'm shadowing you a little bit, Brian, in some of these things. I just finished a great book that a colleague of mine recommended called Freedom's Forge, that you might be familiar with, which fantastic book about how industry was key in the Second World War mobilization of US manufacturing industry to create the so-called arsenal of democracy. And I saw your essays on that as well, and I thought, oh, as ever, Brian's been here about 12 months or 48 months before. Um, in preparing for this podcast, Brian, I think I may have also found my new favorite essay of yours, which is the Energy Cheat Sheet, published in 20th of December 2024. For those in the audience that haven't read something from Brian, I urge you to read that cheat sheet because it is absolutely fantastic. Um, and then I happened upon another essay that you'd written where you explain your process, Brian. And in that, you said that when you're thinking about how to write, you ask yourself, and I'm quoting here, how would I explain the basic ideas in what I've read to an intelligent non-expert? Does that sum up your voice and the tone of the way that you sit down and try to write these posts?
Yeah, pretty much. In the very early days, I would have to like, physically imagine somebody standing next to me and the words that I would say to them if I was trying to explain the topic. And I did that because I don't really have a writing background and writing does not come especially naturally to me. And so to even like get words on the page, I needed to sort of use this little trick to be able to figure out what exactly it is that I was trying to say. And then I guess the other thing is that a lot of these things, I'm not, I guess I would say I'm not the most brilliant person in the world. It is often not amazingly easy for me to understand some new complex topic. And so I really need to sort of be able to have something explained sort of simply and clearly and directly for me to really, really get it. And if it's a topic that, I'm trying to answer some question that I don't have an answer to, I'm the one that has to produce that simple and clear and direct explanation. And so as part of as part of the process, as sort of me explaining these things to myself, I ended up with something that ends up being, useful to other people. Because for a lot of these things, a lot of these topics that I'm writing about, I start out as the intelligent non-expert. For most of the, I don't have a background in, shipbuilding or aircraft manufacturing or nuclear power or anything like that. So when I start researching these topics, I don't know necessarily any more than again, the sort of common person that might be interested in reading one of these things. So that's kind of how that process came to be.
Brian, do you have a team or advisors that work with you on any of this stuff?
No, it's pretty much me. It's pretty much just me. I have a there's an editor at IFP that I work with, and he is that definitely raised the sort of quality level of the final written product because in the very early stages it was just me doing the editing. But on the research and the writing side, it's pretty much just me. I am fortunate that I can, I've mentioned that actually writing, the actual putting the words on the page has not historically been one of my strong suits, but I can research and read and especially skim through things very quickly. So I can sort of digest at a high level not reading deeply, but at a sort of a high overview, a lot of content related to the topic that I'm trying to understand, and I can kind of pretty quickly zoom in on the parts that I need to learn and read about to sort of answer the questions that I'm trying to answer. So I can digest a pretty large amount of written content quite quickly, and that's always been a strength of mine. And then over the, in the past few years since we last spoke, these AI models have gotten so incredibly powerful that those are now really, really key resources that I rely on, and they make it possible to do things that wouldn't, and sort of write essays and do analyses that would not have been possible otherwise. I use them a lot to sort of write software because I don't have like a software writing background, and it would just be the programs or whatever that would be just totally beyond me if I didn't have a sort of computer genie that could just write these programs for me. And so I can do a lot more interesting and complex analyses than I could before with the aid of these sorts of tools. But no, at the end of the day, it's still pretty much just mostly me. I have, I now just have when we last spoke, I was doing it kind of in my spare time, on the weekend nights and weekends and things like that. And now I can just devote all my time to it. And so that has been a major change as well. But yeah, it's mostly a solo endeavor.
Fantastic. Well, it's absolutely prodigious. It's incredible that you do all that on your own, and I'm completely in awe as someone who's, claims to write a little bit and also research here and there. The mileage that you cover is absolutely phenomenal, and not just the mileage, but the depth. And for what it's worth, Brian, you probably had no idea I was going to out myself as a complete fan here, but I think you're right beautifully. So if you're ever sounds to me like you're perhaps being a little bit harsh on yourself there. I think writing is a strong suit of yours, so even if it perhaps doesn't feel easy. Brian, I want to kind of move now to the post that inspired me to reach out to you again after these few years, which is the 50 things I've learned writing construction physics post. In the introduction, we heard you qualify your selection in your own words as, and I'm quoting here, high level takeaways, interesting or surprising facts, and things that gave a major update to my worldview. Was there anything else at work in the selection of those 50 topics?
Not really. So in the earlier day, at one point in the sort of early days of the newsletter, I had sort of a table of contents that was just, here's a bunch of different posts that I've written organized by topic. And that was, I liked having that, but it was very, very just, that was when it was the topics were almost entirely just like, construction focus. And I wanted something kind of similar to that I could use as sort of a signpost and signpost and point something to sort of new readers and here's the sort of things that I write about and here's what this newsletter is all about. And so I kind of but the topics were now much broader and there were so many posts that I couldn't just produce an entire here's a big list of everything that I've written organized by topic. It didn't really make sense anymore. So I just kind of tried to boil it down to some of the greatest hits in a sense, the ones that are either, quite popular or ones that I thought were like, oh, here's something that I think ended up being useful or important. So that's kind of was the origin of that.
Great. Well, it's certainly worked. We clearly can't go through all 50, but I want to do a fast, slow approach if you don't mind. I think it would be great to just do a bit of a spot check of sorts. We'll go through and just pick out three out of the list, get your quick reaction on them, and then perhaps after that we'll come back and go through a few a little bit more deeply if that works for you.
Yeah, that sounds great.
Great. Well, let's start with I'm not really sure what to call them, but I'm going to call it a lesson or insight number 37, which is, and I'm quoting here, AT&T spent substantially more on telephone infrastructure in the 1960s than NASA spent on the Apollo program. Can I ask you, how did you research that, and why does that stand out to you?
So yeah, that one, a lot of times when I'm writing posts, it will start out with just an interesting data set that I discover. And I was like, oh, let's just, get this data together. Let's look into it. Let's see let's see what sort of interesting patterns I can discover in it. And I was able to find online basically a collection of every AT&T annual report from like 1900 to like 1980 or something. So it had all these like statistics on like how much they were spending on various things and stuff like that. And I thought that was very interesting because I think AT&T is a underrated company in terms of like how much, attention and sort of intellectual interest it gets. It was arguably one of the most important companies in the US for a very long period of time. And so I just, I was like, oh, let's see, how much they spent on building out all this like, communications and telephone infrastructure. And it was like, really, really staggeringly enormous amounts of money. And the reason, I think the NASA compare and the Apollo program comparison is interesting because for me, and I think for perhaps, similarly minded folks, the Apollo program is like the prototypical example of like a really huge, enormous mega project, right? You put like,
Yeah.
hundreds of billions of dollars into, achieving this, one specific goal at this one point in time. And the Apollo program is like, the example of that. They spent I forget I think inflation adjusted dollars, it's like $250 billion or something. They employed like hundreds of thousands of people, directly or indirectly. Their spending was something like, like 1% of GDP or something like that. So like, during the 60s or something, it was like one out of every $100 was going to NASA and to the Apollo program. So just the standard thing that I think of is like big, giant, enormous project. And there's very few other projects that like exceed it in terms of like, dollars spent or fraction of GDP spent or whatever. So it's the example that I always think of. And so just, that put the spending on like telephone infrastructure really in perspective for me. It's like, oh, this project that you think is like the biggest project in the world, AT&T was like spending that much, just as the course of like normal doing business. That was how much was effort was required to sort of build out this communication infrastructure. That's how big the demand was for like telephone services and stuff
Wow.
like that. So that's why it's interesting to me.
Yeah, it's certainly interesting to me too. Let's move on. Next, we've got number five, which is, and I'm quoting again, Levittown mass-produced homes were not substantially cheaper to build than other conventionally built homes at the time. Is this one about myth busting, or is there a broader point that you're making here, Brian?
So yeah, one thing, a topic that I'm always interested in the early stages of the newsletter and post Katera, I was very, very interested in it, and it's still something that is, I think quite a bit about, is understanding what it would take to sort of make construction cheaper and more efficient, and be able to build homes and buildings and things like that for less. I think if you could figure out how to do that, that would be a very big boon for humanity overall. And I think the most common strategy that people employ to try to do that, um, or to try to achieve that, is like, oh, we just need to do prefabrication. We need to move, instead of doing this on-site construction, we need to sort of build our buildings and factories. Um, but then there's various flavors of that. And another sort of version of that is people think, oh, it's not necessarily prefabrication that we need specifically. We need to do like mass production, right? We need to do, it doesn't necessarily have to be in a factory, but it needs to be sort of large volume, repetitive construction, building the same thing over and over again. And that's, Levittown wasn't really prefabrication necessarily, but it was kind of this like mass production style of building where you had kind of these reverse assembly lines and like crews going from site to site in these huge 10,000 home developments and doing just like one task and then going on to the next site and doing the same task again, installing
Mm,
stairs, go to the next site, install stairs, go to the next site, install stairs, something like that. And I think sort of people have this idea in this head, and there's the idea that if we could do this mass production, we could build these buildings much more cheaply. And so the problem that we need to solve is to figure out how we achieve kind of this large volume production. And so I think in understanding, the details about Levitt and these Levittown style building developments, and the fact that even with all their mass production methods, they weren't really able to achieve much, if any, cost savings, I think is an important thing to understand. And again, kind of bringing back to what I was talking about early, if you want to sort of improve the construction industry and how we build things, you really need to understand what specifically you would need to do to make that work. You need to have a theory, a correct theory of change that you're trying to sort of implement. And I think most people are laboring under theories that don't necessarily stand up to the harsh glare of reality very well.
I love that. It's something that occupies me and many of the teams I work with quite a bit. And we will come back to the vexed issue of construction costs and productivity. But that is a fascinating one, this idea that mass production and indeed standardization of the buildings will lead to the kinds of benefits. So let's come back to that.
Mhm.
The last in our sort of lightning round of lessons here is number 27, which for me is a real fun fact. And I quote, a bottleneck in semiconductor manufacturing is high purity quartz, most of which comes from a single town in North Carolina called Spruce Pine. Yes, a tree, and yes, a city. I looked it up on Google Maps this morning. Chip manufacturing could probably absorb the cost of switching to non-spruce pine quartz, but this would be much harder for solar PV manufacturing. Are you saying here, Brian, what I think you're saying, which is that all of the quartz used in solar panels is coming from that one place?
No, so yeah, it's a little bit of clarification there. So basically, when you're making semiconductors or solar panels, what you key material in that process is like really, really, really pure silicon, basically. And it needs to be really pure because a semiconductor material won't work if there's like even a really, really small number of impurities, like even a few atoms every million or something, if they're the wrong type of atoms, can like make them
Hmm.
work significantly worse or not at all. So you need to have really, really, really pure silicon to make these things. More important for semiconductors than it is for solar panels. Well, solar panels are semiconductors, but more important for chips than it is for solar panels, but very important for both. Um, and the way that they make this very, very pure silicon is they sort of melt it in these quartz crucibles. And to make your silicon of sufficient purity, you need really, really pure quartz because when these quartz crucibles get really, really hot, any impurities that's in the quartz can migrate into the silicon itself.
Hmm.
So the purity of the silicon is dependent on the purity of the quartz crucibles that they're, being used to make it. And the quartz for these crucibles is that's what mostly historically has come from, yeah, this one mine in in this one small town in North Carolina. So the bottleneck is not the silicon for the semiconductors, for the chips, for the solar panels. It's the quartz for these crucibles that are being used to make this stuff.
Wow, interesting. So I want to move now into our slightly deeper round, looking at some of the things that I know the audience of this podcast are going to find very interesting. And you touched on it there before with reference to Levittown. Uh, we want to get into construction costs, and then I'm going to move on to productivity after that. So coming to point eight, which I think gets to the nub of this, and then a couple of ensuing points. But point eight is for as far back as we have data, that is the late 19th and early 20th century, outside of a few brief windows, construction in the US has never gotten cheaper. So, what a question. And to come back to your correct theory of change, we obviously know that other industries have made their products cheaper over time, and we could list off many such industries. Why hasn't construction? How could you summarize the reasons for this, Brian?
Sure. So I will for one thing, I will say I don't understand this like Fully is one thing that I think there's still like a lot of unanswered questions here, a lot of things
Hmm.
I don't quite get. And I think the extent that this pattern that you see where stuff just, ratchets, the cost just ratchets up over time, the how far back that extends is a little bit of a mystery. Because one is a little bit of part of that mystery. Because one thing that you might answer is like, well, construction methods have not really changed much since the 60s or the 70s. Stuff has changed incrementally, but we're fundamentally kind of building these buildings pretty much the same way that we did, in the 70s or something like that, at a high level. But if you go back to, between like the 1910 or 1920 and 1950, there was like massive change, right? That was when,
Mm.
you had changes going from like plaster to drywall. That was when you had introduction of like power tools and stuff like that. Truss plates, all these, that you have, major shift in like technological change that's used to like put buildings up over that period. And even with all that change, you still don't see costs really declining over time. And so that's why I think there's still like something of a mystery, something I still don't really fully understand. But at a high level, that my answer to your question would be something like, we've steadily made it like in the US, and we steadily made it more expensive and more difficult to build things. We've sort of, labor costs have gone up, that we've added more rules and regulations. There's, environmental studies and things that have to, done that didn't have to be done historically. All the complexity of getting these things built and the overhead and sort of the bureaucracy and the process involved has all ratcheted up. And there hasn't been a commensurate improvement in the sort of technology and the process that we use to actually build these things that can offset that and drive these things to kind of um, be cheaper over time. And then, so that's the high level answer. And then the sort of more specific things. Um, why we haven't had those process improvements. There's, a lot of kind of more complex reasons for that.
Yes, I would certainly agree with the complexity. One of the things that I've written about before is this trope of thought that you find quite often in new ventures, in construction, is thinking that the problem is easy. It feels to me that anyone that doesn't really understand the complexity of the industry and its processes as they currently exist, or its business patterns, is probably already doomed to fail somewhat, because it is a very complex system. But following on from that, and we will come back to productivity around some of those observations that you made there about making building more expensive and difficult to build. A following point that you again alluded to earlier is point two, which is prefab construction is typically not any cheaper than conventional on-site construction, either in the US or around the world. When it is cheaper, it's often because it takes advantage of low cost labor rather than for efficiency reasons. Obviously, this is something that many of our listeners may have heard before on this podcast. Could you give us your view on why this is so, especially given the overwhelming promise of prefab, if you like, that it can lower costs?
Yeah, so this is another, topic where like again to dive into it, there's a lot of like complexities and nuance and there's also many parts of it that I do not fully understand, don't have all the answers. But sort of I would say a big part of it is moving a process into a factory does not automatically make it more efficient. What makes it more efficient is that when you do something in a factory, it allows you to do certain things, certain different specific improvements, and those improvements are what actually makes your process more efficient. And those specific things that you are able to kind of do are that to actually, the things that you need to do to make your process more efficient, they are all kind of hard to do in construction, or they don't yield maybe the as big a benefit as they do in sort of other industries. And at the same time, with construction, when you move something into a factory, you incur a lot of other additional costs that you don't
Mhm.
incur if you build something in the more traditional, more conventional manner. I know I've talked to some contractors who talk about like the prefab tax of all the other stuff that you have to sort of
Yeah.
deal with and pay for if you convert your sort of conventional building into a prefab building. Some of these sort of tax items is you have to pay shipping costs that you didn't have to traditionally because you're moving these like sort of big bulky components over over a long distance that can often be quite expensive. If you're building into modules and stitching those modules together, you need some way to connect them together, and so you have all these different connectors and of that you would not have to have if you sort of built your building in a more conventional fashion. You probably need like additional framing to make your parts of the building survive the trip or be able to be lifted into place that you wouldn't need in sort of a more conventional in construction. So there's all these sort of little additional costs that you incur. And then on the sort of, on the benefit side, there are definitely benefits that you can achieve by, moving your stuff into a factory, but they tend to be not as big as, as maybe you would hope. Oftentimes what you see is someone doing when they're doing prefab, um, it's really sort of they're kind of doing like very conventional construction. They're just doing it inside of a big factory building, right? But it's still the
Yeah.
same work being done in like the exact same way. You have like, drywallers up on stilts going around to these buildings and, drywalling the inside of modules and stuff like that. And sort of a lot of the things that you can do with that you would want to do in a factory, stuff like automating processes, either very hard to do or you can do it, but you don't yield like really enormous benefits of it. So like, stuff like drywall, that still is pretty much going to be done mostly manually. And the stuff that you are automating, if you're doing something like automatic like wall panel fabrication with like a robotic
Hmm.
wall line or automatic truss fabrication, the equipment that you need to like do that is really quite expensive, and typically your throughput is not really that big, and so it takes a lot of equipment to sort of duplicate what basically a very small number of workers can do with like hand tools.
Yeah.
And so the sort of forces there are just often tend to be a little bit unfavorable for the economics of doing this stuff in a prefabricated fashion. You can definitely build a successful business doing this sort of thing. You can be competitive in the marketplace, but you don't what you typically don't see is somebody like moving their process into a factory and then they are achieving the similar sorts of gains that Henry Ford did when he created
Mm.
his their line, right? Just like these enormously massive efficiency improvements that are so huge that you just can't go back to the old way of building. It just sweeps the old way
Yeah.
away. That is not what you see.
Yeah. I love that reference to Ford there. Gilbert Herbert, like one of the major scholars in this area, referred to that as the Henry Ford syndrome.
Yes.
That people would start these ventures thinking it must be possible to do what Ford's done in the factories, and then only to find exactly as you've just portrayed that it isn't that simple.
Yeah, that's
One of
that's
the
what the
other
people
thing,
at Katera were trying to do. And if you go back in history, you can see other people like, you know, hubristically declaring themselves the Henry Ford.
hmm,
And it
yep, and it's
rarely
still
ends.
going on today.
Yeah.
Yeah, there's quite a bit of amnesia in our industry. Let's put it that way, Brian. So, look, one of the other things I like about your newsletter, Brian, is that you will also take a contrary position, and so we don't have to look far here because if we get to learning number three, it states that a big exception to the above, i.e., number two, what we just discussed, that prefab is often not cheaper, is manufactured or mobile homes, which are substantially cheaper than conventionally built homes. Now, we had only a few weeks ago Professor Ivan Rupnik on the podcast. He told us about some of the work that's going on at HUD, which is famous for creating the HUD code that applies to manufactured and mobile housing. Um, so I'm interested to hear, how do you think the manufactured housing industry got costs down?
So this is another thing that I don't understand like amazingly well. And I think this is, something that would be valuable if it were understood better. I always thought that, people doing prefab or people trying to sort of change, with a mind of changing the industry, this is the first place that they should be looking because this is like one place we go, hey, we're building stuff much cheaper than conventional construction. People should be, lining up outside the factories to understand exactly what is going on. And you don't really see that, unfortunately. But it's sort of the extent that I do understand what's going on, I think there's a couple of different things. One is that a lot of times manufactured or mobile homes, they're built to sort of, they're built to like a lower level of finish, right? So they're using like, targeting a lower part of the market. The
Mm,
stuff that's going into them is a little bit less fancy, a little bit less nice, maybe. Using lower end materials and things like that, using vinyl board on the interior, with seams in it on the interiors instead of like drywall and stuff like that. And so that's part of it, but that's not all of it. Because even if you build, even if you compare like for like, manufactured homes can still be cheaper than conventional construction. And another big one is that manufactured home construction is works the best in sort of a very narrow set of form factors. Where it really works the
mm,
best is if you're building something that's roughly like trailer shaped, like what's called like a single wide, which can just, be fit
mm.
in like a single trailer. It's one unit, you just drop it into place, and then you're done. The more something like that, the lower that its construction costs are, and the construction costs for like single wides are quite low indeed. But the more that you move away from that form factor and into something that like resembles more of like a traditional building and sort of like maybe has complex, exterior features and stuff like that, the more that sort of the advantage of manufactured homes kind of get chipped away. So if you go to like, double wides, which are two modules put next to each other, that sort of cost per square foot goes up. If you go to triple
Yeah.
wides, 3 units, the cost per square foot goes up again. If you go into sort of things that like, porches and, complex overhangs and other sort of more ornate building features, the cost advantage really tends to get whittled away. And so it works very well in like a particular form factor that's well suited for it. But as a more general solution to construction more broadly, you kind of see its advantages get eroded a little bit.
Yeah, it is very interesting. And it was my understanding from having visited HUD myself earlier this year and speaking to Ivan, is that there are kind of two streams of work around, what I would refer to more broadly as the industrialization of building, if you like. One is through the HUD code and the manufactured homes, and the other is looking at the use of prefabrication in the conventional housing market, and trying to get some of those costs down there, where it strikes me that there is a very large emphasis on regulation and the way that that works. Um, I It would be great to move now to productivity. Brian, I think this is a really hot topic right now, certainly here in Australia, and I think in other parts of the world. Um, I specifically would draw your attention to learning number 17, and I'm going to quote a little bit at length here. Construction in general has gotten slower in the US over time, but the contours of these speed changes aren't uniform and are sometimes surprising. The speed of New York skyscraper construction has fallen by more than 50% since 1960s, but in Chicago, speeds are down just 10% from the 1960s, though the decline from peak speeds in the 1970s is greater. Today, Chicago skyscrapers are built roughly twice as fast as New York skyscrapers. Brian, that's a fascinating insight. it accords with a lot of the data that we've seen from around the world with declining productivity. What accounts for this difference, both from the 1960s to now, but also between New York and Chicago, in your view?
So I guess one thing I would want to clarify first is that I consider there's a big difference between productivity and construction speed. Where
Hmm.
construction speed is just, how fast that you can, build this thing. And productivity is basically how many, how much are you getting out per unit of resource in. And
Yeah,
it's
yeah,
very possible to have very, high productivity without necessarily being very fast. If and on the conversely, it's possible to sort of build very, very quickly and not necessarily be particularly productive or efficient. An
hmm,
example of that of ladder is this is sometimes you see in something you will see in China, where you'll see them build something very, very quickly, a building or a bridge or something like that. But often they accomplish that by just throwing like an enormous amount of labor at the problem
yeah,
to get it done all at once. So they're building it very quickly, but they're not necessarily, I don't know for sure whether they are or not. That doesn't, they are clearly using a much greater amount. They're accomplishing that by putting much more labor on a project than you would traditionally. So if you divide it by the, the total amount of labor they do in terms of like output per labor hour or something, it may not be better. Um,
yes.
so yeah, but I think this sort of New York and Chicago and international construction speed things are very interesting. For New York specifically, I'm not an expert on this, but it's my understanding that New York City has a lot of extremely burdensome rules and regulations surrounding building that makes it a lot more difficult than it is even in other like major U.S. cities. I think they have very strict rules around like what kind of cranes you're allowed to use and stuff like that. I think in New York, it's actually pretty rare to see a skyscraper built using a tower crane, which would be like the
Mm.
standard way of putting up a building basically anywhere else. They are, for some reason, they are very, it's very difficult to use those sorts of cranes in New York. They have really strict rules about like um site safety and like leading edge safety and having enough scaffolding and stuff like that. And I think all that makes it just like quite difficult to build these buildings in a way that is not necessarily in in other places in the US.
And do you think there's something about complexity at play here, Brian, as well? One of the very early podcasts we had was a world-renowned fire engineer, Professor Jose Cullen Torrero. And Jose would say that, um, in some cases, the complexity of the systems that we've begun to develop, particularly around cladding and particularly in some cases, the use of indeed flammable products in cladding and in facade structures, has meant it's very difficult to guarantee their safety. In terms of productivity, do you see the complexity jump, let's say, between 1960s and today as being one of those factors as well?
Yeah, that's an interesting question. There's definitely some things that have, gotten more complex. Their buildings have many more services today than they did, historically. Um, and oftentimes these like services that do exist are being tasked to sort of do more involved jobs. Like I'm not an expert. I'm quite sure that the climate control in like a modern building or skyscraper would be much, is doing a much more complex job than it was in the 50s or 60s or something like that. So I'm sure those sorts of things have gotten more complex. And then another sort of additional area of complexity that you see is in like code requirements in regulation.
Mm,
This is something that I noticed a while ago. And this is something that, to go back to the manufactured homes and the HUD code, they have the benefit of being under a somewhat simpler code that doesn't get updated very frequently. And
yep.
modern building codes in the US, they get updated much more frequently, and often these changes make them much, much more complex over time. If you look at like the thickness of of one of these like code books, it gets thicker and thicker and thicker and thicker as the years go by. And often that's because like the sort of models and the sort of, requirements that they're trying to implement have gotten a lot more involved and detailed. And oftentimes it's not necessarily that the actual requirements are getting stricter necessarily. It's just that the implementation is getting a little bit more involved. So an
Mm.
example that I can speak to a little bit, like the HUD code uses a sort of a very old version of the wind code. I believe it uses a code called for how much wind load a building needs to withstand. I believe it
Mm.
uses what's called the ASCE 98 code, which is a wind code from 1998. And that's a very, very short code. It's like 100, 200 pages or something like that. And more modern building code will let you a much more recent version of ASCE. And then if you look at those code books, they've gotten much, much, much thicker. But if you look at the actual forces involved, it's not necessarily that the forces are higher today than they were in like the 90s or whatever. It's just that the way you have to calculate them, the methods for calculating them have gotten much more precise. And so
Yeah.
it's much more involved to do these calculations than it was historically. Not necessarily at the end of the ultimate forces are higher or anything like that.
Um, so coming back a little bit to productivity and the issue you just mentioned about code and regulation more generally, we had the head of the Australian Productivity Commission on the podcast as well. They were looking at housing construction productivity and its decline specifically in the Australian context. And I can recommend that podcast and the associated report for any of our listeners who may not have caught that. The three main lines of addressing the issue were outlined as, broadly speaking, innovation. Secondly, regulatory reform, and then thirdly, boosting the workforce and their training. Um, would you agree with the CEO of the Productivity Commission in Australia? Is it innovation, regulation, and sort of workforce changes that will get us to productivity, or is there something else in the basket, Brian, that you would recommend?
Yeah, I think at a high level, those are all very good ideas. Regulation is, again, I think is certainly a big part of it. Innovation, I think that's a little bit non-specific for my taste. People
Mm.
trying various ideas that I think are innovative, and often that those things do not work or do not really move the needle. Kind of where I come from in this is that you really, if you're going to make a change to some sort of industry and, or improve things for the better, you need like a theory, like a hypothesis of what specifically is causing these declines and, or lack of improvement and how some given intervention will fix that. And so I think if you want to make some improvement, you need to have that good theory and hypothesis. So I think at a high level, those ideas are good. I'm not sure that they are really specific enough to be
Hmm.
sure that you will get the results that you are hoping for. Because people have been trying to sort of improve those, things in those avenues for many years and decades. And so I think, I would want something a little bit more. I would want to, that's what, a good for a starting point, but it's only a starting point. You need to drill down and think about like what the specific changes you need to make are and how you can sort of allocate your resources effectively along those lines.
Yeah, look, I would agree with that as well. And it was actually a quite short report, but a lot of the work is clearly yet to be done there. Uh, Talking about these issues a little bit in code and regulation, again, in preparing for this, I sort of went back through your archive a little, and I'm a fan of Ezra Klein's podcast and certainly his book with Derek Thompson, Abundance, is having a bit of a moment right now. As I'm sure you're probably aware, Brian, there's quite a bit about housing and big projects and infrastructure. And like most things, Brian, you're always first into the fray there, and I really liked your article, which is titled "Klein on Construction." from way back in 2023. And if I understood correctly, and sorry to be pulling this one out of the archive at you, but if I understood your point correctly, Ezra Klein is making the same point in the article that you are discussing, which goes into his book Abundance, which is really a case for saying burdensome regulations and overlapping approvals and certifications have been perhaps the major thing that have driven up costs and productivity. And if I understood your position in that particular article a little bit, you sort of do your now customary sort of sleuthing in the background, armed with actual figures and real spreadsheets and tables. And yeah, if I understood you, your point is perhaps those things are not as big a contributor as certainly Ezra Klein would think. Could you maybe speak more to that, Brian?
Sure, I'll do my best. I will confess that for older articles, I often do not remember specifically what.
Oh, we'll forgive you, Brian. There's 186 of them. Yeah.
Yeah, part of the reason I have to write everything down is because otherwise I will forget it. And so, but I think so. My recollection on that one is that he's looking at the problem of construction productivity and talking to people and there's so many like approvals hoops that you have to jump through for to get approvals or whatever. So many people have to like you know uh, sign off on a permit, so much time it takes to kind of get these permits and stuff like that, and how that's a very big problem. And that it is a very big problem. He's not wrong about that. My sort of point was like a kind of somewhat of a abstruse technical point, in that the construction productivity problem is a little bit different than that.
Mm,
Because typically, the sort of those sort of things with like permitting and approvals before the project starts, that doesn't really get counted when you're trying to add up these like construction productivity things. That when you're talking about construction productivity, you're talking about like hours it takes to do a certain task or something like that, and sort of these questions of like approvals and environmental studies and all the stuff that you have to do before a project even starts. That stuff isn't really typically included when you're sort of making these construction productivity calculations. So they're really kind of a little bit two separate problems. So if you fix your environmental processes or whatever and streamline all this permitting and stuff like that, it's not really probably going to resolve your problems of construction productivity specifically. It's going to make your costs overall better and everything smoother and being able to get things done more rapidly. So I'm not saying that it's not a problem that needs to be solved, but just like it's sort of a technical point on like what gets counted in these various measures and what doesn't, and what these buckets of cost include.
No, I think that's an important point because we do hear a lot of things being waved around at the moment in this discussion around productivity, and I think it's good to start with the facts. It's, as you said previously, having a correct theory of change is important here, and we want to know that we're asking the right questions. So I do feel it's important there. Brian, before we move to wrap up, I want to just get your feeling on a kind of innovation topic, if you like. You said before that, just simply broadly pointing to innovation is probably a bit too diffuse for you. We want to see more detail there. I think historically, if I'm trying to summarize a very wide and general body of discourse, I think in many cases, the the idea of prefab or modular building or offsite building or factory built housing has often stood in for innovation in many ways, like a synonym, if you like. When we think about what innovation could look like, we instantly grab for prefab. So I actually think, in the case that we were talking about before, that's probably what most of the policymakers have in mind. But the question I've got for you is that I've often wondered if the lack of innovation in building, or as you mentioned it before, the reasons that we haven't seen wholesale innovation and massive jumps or reductions in cost and boost in productivity relative to other fields is because of the size of building. Is it because of the bulk? Often I think of building as sort of very large quantities of dumb stuff, and not to mention the risks associated with buildings as a particular type of thing in the world. Now, I can clearly point to the counterfactual here, which is that, you make a post, indeed, it's called number 48, which is about, the body of work that goes into a new commercial airliner, which is huge and extremely complex, in many ways more complex than a building. I just wonder what your thoughts are on this topic of the resistance of the building industry to change and innovation and its size and risk.
Yeah, so I think like yeah, the physical size of buildings is definitely a big part of that. It really limits, how much you can do something in a factory because there's, with the size and the fact that you're having, making this thing that's going to be installed in a specific location and hooked up to services and embedded in the ground into a foundation, that's always going to require a certain amount of like on-site work that, this minimum amount of like, site efforts that just can't be getting rid of. And it makes it, it definitely makes it harder to do this stuff in a factory. But I think a good point of comparison here is not necessarily aircraft, but shipbuilding.
Mm,
I've spent a while reading about shipbuilding, initially specifically because um, I thought it would be have, possible lessons for construction because these are like these so really huge, physically large, structures that are in many ways resemble a building. It's like a ship is like a building that can move around and that people can, move around within. But shipbuilding has actually been able to see pretty substantial um, productivity improvements over time. In the 50s and 60s and 70s, Japan went from building a relatively small fraction of the world's ships to building more ships than anybody else. And this was in part because they were able to really, really improve the productivity and they were able to, decline how the time and effort it took to sort of build one of these ships. And so you have to sort of, the bulk of it is part of it, but you have to understand that and how it intersects with kind of all these other factors where how such things like again it's sort of a complex story but there's things like buildings are built with like really inexpensive materials like
hmm.
wood and drywall and stuff like that is some of the cheapest things that we make at all and so it's hard to like sort of substitute out those for other materials that might be a little bit more amenable to sort of automated style construction processes. A big way that shipbuilding got cheaper over time was like really improving the welding process and be able to automate a lot of this welding. But if you couldn't, it would be very hard to sort of do large scale welding in sort of a single family home that's made out
Yeah.
of wood, right? The cure would be much worse than the disease there. And then also, ships have the benefit that you can do all your building like one specific place, one shipyard, and just move it so wherever it needs to be without much difficulty. Ships are designed to be moved after all, and a building is sort of not designed to be moved, obviously. And so it's like the bulk combined with kind of these other sort of difficult constraints that all work together to kind of conspire to make productivity improvement really quite difficult.
Yeah, it is. It's very complex, but I think yeah, there's some really interesting insights in there, Brian. Size really does matter, and the sort of simplicity or of the material types, as you say, doesn't lend itself to perhaps some of the other more advanced technologies and processes that we've seen in other industries. I want to move to wrap up now, perhaps with a bit of a lightning round, Brian, if we may. Um, I want to start this by asking you, what advice would you give to someone else who wanted to start a blog or a newsletter or develop content in the way that you do in this space?
Oh gosh, interesting. Yeah, I'm very much of two minds about it. One is that in
That you're
general,
saying don't do it.
well, in general, like the statistics for like, if you look at statistics for like, writers and whatever, it's very like you're trying to do it to make money. It's a very tough road to hoe, I would say. And so I would say don't try to get it into it to make money because most statistics show that the people are able to do that are very few and far between. On the other hand, that I will say is that I think there is a very great dearth of people willing to just put in a lot of time and effort and sweat to try to understand, something and put in, trying to come up with an answer to a question or try to explain why something works the way that it does and put that explanation down in a way that is sort of understandable to people. I think there's lots and lots of things that I would like to see people, people spend more of their time and effort explaining, various things that I don't, I wish I understood better. And I think there's sort of lots of opportunity for those people to do that, do those sorts of things. I think if, just being willing to put in a lot of time and effort to try to understand something and try to make something that's good and that you're proud of and is valuable to people will sort of put you, even just being able to willing to put in that effort is going to put you in sort of the top tier of, quality on in certain areas and on various axes. So if you're willing to put in the time and that effort to sort of understand these sorts of things and to put your sort of understanding into words and on paper and on the internet, I think there's a lot of value in doing that. And I think people will generally respond to it.
Um, what do you wish people would ask you in the interviews like the one we are doing right now? A question you wished you were asked, but somehow it just sort of never seems to come up.
Oh, yeah, that's a good question. Um, I
Is
don't
that the
really, I
question?
don't, yeah, I don't have a good answer to that, unfortunately. I'm usually quite pleased at the questions that I get. I'm always happy to talk about my work, and they usually sort of, I think, do a pretty good job of dissecting and asking about the various aspects of it.
Okay, well that's fine too. What do you think is perhaps not getting enough attention in building? What area of investigation would you like to see more work in, or more, to use your term, effort, sweat, and time put into?
I'm very optimistic. We've talked a lot about productivity. I'm very optimistic about like progress and automation eventually solving a lot of these productivity problems. So, some sort of like, robot or whatever that prevents you from having to sort of need a factory and have some like really specific, narrowly done process, which has historically not worked very well. Robotic advances in robotics, I think, are going to really change the landscape here quite a bit. And you're seeing that to some extent in construction. You're seeing, startups doing various robotic solutions to sort of various problems. But I still think the opportunity there is really it's either good right now or if you can kind of see where the puck is going, it's something that is going to be there in a few years is because there's all this money and time and effort is going, being invested in kind of these general purpose robotic solutions and, efforts from AI, which is of course absorbing, hundreds of billions of dollars, is now kind of getting redirected into robots as well. And so I think that technology is going to really start to get more and more impressive. And I think the way that's going to be more and more applicable to construction. So that's something that I monitor quite closely. is progress in robot and advances in robotics, and I think that is going to be a pretty big opportunity in construction in the near future.
Well, Brian, I think that's a really good place to leave it. I want to thank you for your time today, and for our audience, the notes and references that Brian and I have spoken about today will be added online to the show notes. Today, I also want to thank our wonderful editor, Dr. Sarah Breen Lovett, who's been doing the editing of this podcast since the beginning, and also Michael Hogg for the theme music. So thanks again, Brian, and thank you to the audience for listening.
Thanks for having me.